Okay, today our learning target is I can calculate the volume of a solid constructed from unit cubes, and then we are going to work on this learning target today. I can also work on this learning target today. I can develop and use a formula to find the volume of rectangular prisms. Okay, first thing I want to talk about is what do you think of when you see that word volume? This is a multiple meaning word, which means you're probably thinking about sound volume. And I just want to remind you in math that volume is the amount of space an object takes up. So what we're going to be working on today is mostly rectangular prisms and cubes. Okay, this is just a little quick review. So what we did 2 weeks ago is we worked on finding how many cubic units were in a solid like this, an irregular solid. So the way that we did this, we did it a couple different ways, a couple different strategies. First strategy is you can just count how many cubes are in here. Now, the issue with doing that is you see how this is 2 layers high? So what that means is there are some cubes back here on the bottom that we can't see. So what we decided to do was to count what we can see and then kind of almost make like a educated guess on the cubes that are there. So for example, I count 3, 6, 9 on the top. So what I know is that there are 2 layers of 9 here and here. That makes 18. Then I counted 19, 20, 21. And we called these cubic units. The reason why is because these little cubes right here that make up that solid are what we are counting. Okay? Remember, this is different than surface area. Surface area is just a flat, plane shape. Now we are counting 3-dimensional cubes. Okay? And here's another example of that. Now, we're not going to do this all together. Now, today, you're going to see figures that are a lot more regular, like this. And so what we are trying to find is how many cubic units make up these solids. So one strategy that we're going to use today to do this is just by counting them. 2, 4, 6, 8. 8 cubic units. But you're also going to find, kind of like we did with irregular solids, that isn't always super effective. So the same thing's happening right here. I can see that if I go to count these, I'm going to be missing some of those cubes. I can't see all of them because of our solid. Okay, so what we're going to do on this slide is we're going to find how many cubes are in layer 1. And we're actually going to cheat a little bit. I'm going to call layer 1 this top layer because what we can do is count these 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. There are 16 unit cubes in layer 1. So what does that mean we know about layer 2 or that layer underneath? It also has to have 16 unit cubes. So if we want to find out how many unit cubes there are together in this, we can either multiply 16 times 2, or we can add 16 plus 16. Either one of those that's fine, up to you. 32 cubic units. Okay, moving on. So we can do the same thing with this shape here. We're not actually going to do that one. Now, the other thing I want to remind you of, and this is very related to surface area, is that we are going to use our 3 dimensions of cubes to help us find volume today. So we're going to use the length, the height, and the width. Okay? Now, if I wanted to find this, let's go ahead and label these sides. So let's label our length, our height, and our width. So go ahead and look at this. How many cubic units make our width? 2. How many make our height? 2. And 1, 2, 3, 4 make our length. Oops, okay. Now, let's go ahead and practice this one time. Our goal today is to develop a formula to find the volume of solids, which we may or may not get to today. That is okay. This solid is made up of 1-foot cubes. So before this, we're just talking about cubic units. Now we're actually going to say that our cube has a side length of 1 foot and 1 foot and 1 foot. Okay, so that's actually a really big cube. So if you were to zoom out of this, zoom in on one of these solids, you would have this cube. Okay, so this solid is made up of these. Now let's go ahead and label our length, width, height, and then we'll work to find our volume. Okay, so length, I'm just going to count 1, 2, 3, 4, 5. width, I'm going to count 1, 2, 3, and height 1, 2, 3. Okay. Now, what we could do is we could find the area of this base or find out how many cubes make up this top part, which I see we have 3 rows of 5, aka 3 times 5. That gives us 15. And then we can look here. Do you see how we have 1, 2, 3 layers of 15? So what we're doing is we're going to end up multiplying 15 times 3. 45 cubic feet. Also, here's where you might see that little baby exponent 3, like that. And 3 means cubic, because when we look at our cube, we are finding how many of them are in here. Do you see now that this has a length, a width, and a height? We are multiplying how many dimensions? Yep, 3 of them. So if you get this far today, on your practice, just a reminder, we're going to work on developing this, but our formula for finding volume equals length times width times height. You could also find volume by finding the area of the base times how many layers you have, or times your height, which is kind of what we did here by finding 15, and then we have 3 layers of 15.